Good afternoon, students, and this is going to be our 5-4 video. We're starting it off with the review of the quiz on Friday. If you did not take the quiz on Friday, you must take a alternate quiz on Monday when you come in. Please make sure you're ready for that. You have to take it. Please remind me when you walk on the door Monday morning that you need to take it so you can do that right away. You will not do a mind warmer. All right, so let's go ahead and start the quiz. Okay, so the corrections are for number 1, the answer is D. And the answer is D simply because we are looking for the measure of the interior angles of a regular octagon, which has 8 sides. So we take that 8, we substitute into our formula that we actually created to figure out how many triangles are inside of this regular octagon. And there actually happens to be 6. So 6 times 180 gives you 1,080. And then we want to take that and actually divide it by, well, the number of actual angles inside, which are 8. And that's how we get the 135. Question number 2. The pentagon of the diagram below is formed by 5 rays. So here are 5.5 angles in the triangle. Just want to make sure I note these. 1, 2, 3, 4. That one's an angle. 5. Okay? And all 5 of those, because this is a pentagon, means they have to add up to the total amount of angles inside of a pentagon, the interior. So again, we're going to use our 5 here. 5 minus 2 gives us 3. 3 times 180 gives us the 540. Then we want to go back and say, well, if all of these angles have to total 540, then I'm going to subtract 112, which is the difference between 68 and 180. 96, which is the difference between 84 and 180. And then over here, I'm going to subtract 120 because that is the difference between 60 and 180 and the 140 that was given. When I subtract all of those from 540, I'm left with 108 degrees. That is why the answer is 108. That's why the answer is 108. Question number 3 says, in which polygon does the sum of the measure of the interior angles equal the sum of the measures of the exterior? So we're looking for a polygon that has the same inside and outside. And lo and behold, that actually happens to be quadrilateral. Again, 90, 90, 90, 90 gives us 360 in, and we know that all exterior angles are going to total 360. Therefore, quadrilateral is what works. Number 4, in the diagram below of the parallelogram STUV, what we're looking at is SV, VU, and TU. I labeled them as shown, and you just have to understand that if it's a parallelogram, you know that the opposite sides are going to be congruent. So when I set these two equal to each other and solve for x equals 2, and then I go back to answer the question, which is length of SV, okay, I'm actually going to plug in 2 here, and I'm going to get 2 plus 3 equals 5. That's why the answer is A. Okay, question number 6. Which statement is true about every parallelogram? So again, you just kind of want to go through these and separate the ones that don't make sense. All 4 sides are congruent. Well, not in every parallelogram. The interior angles are all congruent. Well, again, not in every parallelogram. Some have opposite sides congruent. And then for D, the diagonals are perpendicular to each other. Again, not in every parallelogram. Some just bisect each other. So 2 pairs of opposite sides are congruent. Absolutely. In every parallelogram you will ever see, that statement is true. Number 6. In the diagram below, parallelogram ABCD has diagonals AC and BD that intersect at point E. Which expression is not always true? Okay, not always true. So this could actually be false sometimes. So here we go. DAE is congruent to BCE. Well, that's always true because these two are actually alternate interior angles. Okay. B, DEC, use blue now, is congruent to BEA. Oh, well, these are always vertical angles. Let's look at D. DE, use black now. DE is congruent to EB. Okay, so we're thinking right now, yes, this is going to be true. Always going to be true because that is one of the things, they bisect each other. The diagonals bisect each other. So diagonals bisect. So the only thing left here is C. C is the one that is absolutely not always going to be true because remember, the diagonals are not always going to be equal. They may bisect each other, but they're not always going to be equal. We will look at some cases today where they actually are going to be equal. Just very quickly again, the video will be a little longer today because I had to review a quiz, but again, going forward on the weekend, that will be the case. Okay, so our objective today is I can prove quads are rectangles, squares, rhombi, and trapezoids by using their properties. We will actually look at trapezoids tomorrow, but again, that's the basic idea of what we're looking at for the next 2 days. And the Excel skills that I'm going to suggest you start are going to be N4 and N5. This is video 5.4, so please make sure you note that down. So here we go with our first definition. A rhombus, okay? A rhombus is a parallelogram with 4 congruent sides. So I'm going to draw a rhombus. And a rhombus, again, just has 4 congruent sides. A rectangle. A rectangle is going to be a parallelogram with 4 right angles. So if we think about, again, what a rectangle is, it's got 4 right angles. Okay? And a square. A square is going to be a parallelogram with 4 congruent sides and 4 right angles. So if you're thinking, well, a square is pretty cool because it has both the features of a rhombus and a rectangle, then you are right. It actually does. So just make sure you're marking it correctly. So let's talk about the diagonals, the actual diagonals of these figures. So if we have a rhombus, if we look more closely at a rhombus is really cool in the sense that a rhombus, let's draw one here. A rhombus, while it has its 4 sides congruent, also has diagonals, when you draw them in, that actually are perpendicular, which means they meet and form 4 right angles. Okay? Diagonals also are going to bisect the angles that they are there. So they bisect the angles and they cut them in half. And that's something that's going to be very useful later on as we look at it. Okay? Now, a rectangle, these are the diagonals that you've been waiting for. If you make a rectangle, the diagonals here are going to be congruent, which means that we already know that every parallelogram, and a rectangle is a parallelogram, is bisected. So the pieces are going to be, this is going to be congruent to this piece, and this piece is going to be congruent to this piece. But now the entire diagonal is congruent to the other entire diagonal. So let's look at some examples. Here's example number 1. It says, is parallelogram KLMN a rhombus, a rectangle, or a square? Explain. So let's look at what we have. We've got some right angles marked, and we know it's a parallelogram. So if it's a parallelogram, we know that these 2 angles here, let's call this angle L here, okay, plus angle K, have to add up to 180 because consecutive angles are supplementary, and that's from parallelograms. So if K is 90, then L has to be 90. That means that we have 3 right angles, and the same thing is true about N. So now we've got 4 right angles, so this definitely has to be a rectangle. It has to be a rectangle because we have 4 right angles. Okay? We can't say it's a square because we don't know anything about the diagonals right now. They didn't tell us anything, so that's all we can say. All right, moving on to question number 2. If we know that NL is 11.5, okay, so NL, and that's our diagonal here, they want to know, well, how big is KM, which is the other diagonal? And if we have a rectangle, then we know rectangles, the diagonals are congruent. So that automatically means that KM is the same as NL. So that means KM is going to be 11.5. Okay. Number 3. HIJK is a rhombus. Okay. So what are the measurements of IKJ and HIK? Okay. So these 2 angles here. So we know with the rhombus that the angles are bisected by the diagonal. So that means these 2 angles are the same. They're congruent. They're equal. So if we set them equal to each other and then solve this for x, we will find that x equals 11, and then go ahead and substitute xn as 11 into both smaller angles. We will find out that IKJ is going to be 63. And hey, HIK equals 63 too. And that's also what we were supposed to find because we know these are going to be congruent. All right, so here's the secret hot question. It says your class needs to find the value of x for which parallelogram DEFG is a rectangle. A classmate's work is shown below. What does the error explain? So the top we've got 9x minus 6 and 2x plus 3. And they're trying to add them together or set them equal to each other and finding x equals 2. So what is the error you want to explain? I will see you tomorrow. Have a great rest of your day.